Modern physics relies on a tenseless, four-dimensional space-time formalism to map the universe. Four-dimensional space-time is a mathematical model that fuses the three dimensions of space and the one dimension of time into a single coordinate system. By mapping events this way, the equations eliminate the need for a universal now, allowing physicists to calculate invariant relationships across any reference frame. Because this geometry is so remarkably effective, many theoretical physicists conclude that reality itself is a static block universe, a structure where past, present, and future exist equally and simultaneously. This idea took root early in the 20th century, heavily influenced by the mathematician Hermann Minkowski, who first proposed packaging Einstein's mechanics into this elegant four-dimensional geometry. Concluding that the universe is a solid block of events is a category error known as the reification fallacy. The reification fallacy is the logical mistake of treating an abstract mathematical mapping tool as if it were a concrete, literal object. A globally defined set of coordinates is a way to compress and represent data, not a completed metaphysical inventory of everything that exists. An alternative model, known as the Changist framework, discards the static container. When you strip away the interpretive overlay of the block, what remains in the data is a dynamic network of light cones and world lines. In this model, reality is composed strictly of ongoing physical change and the creation of records, with no need for a frozen, pre-existing future. Confusing the map for the territory obscures the actual physical mechanisms that allow us to observe the universe. When we mistake a mathematical convenience for structural reality, we stop asking how evidence is physically generated and maintained. A common defense of the block universe is that Albert Einstein's theories of relativity mandated. They do not. Special and general relativity dictate that there is no universal, frame-independent simultaneity. They do not dictate that all events across time exist simpliciter, or all at once. What relativity actually privileges is operational temporal structure. It enforces an invariant local causal ordering, dictating which events can physically influence others via light cones, and it measures proper time, which is the exact physical accumulation of change along an individual object's distinct world line. General relativity does occasionally allow for universe-wide time slicings, but only under a condition called global hyperbolicity. Global hyperbolicity is a highly specific mathematical property that permits a spacetime manifold to be smoothly divided into distinct spaces across time, ensuring predictable equations of motion. It is a special case mathematical condition used to make equations solvable, not a default physical reality of our universe. By stripping away absolute time, relativity ensures that objectivity is only achieved locally. It happens specifically at the intersections where physical systems meet, exchange signals, and sync their internal clocks. Relativity mandates a highly localized, relational view of how systems interact. It clears the ground for a dynamic, process-driven ontology without ever smuggling in the requirement for a static, four-dimensional totality. To understand reality without the block, we have to look at how we gather evidence, a concept known as public re-identifiability. Public re-identifiability is the requirement that scientific objectivity must be grounded in the creation of stable, shareable physical marks that multiple observers can independently measure. In a static block universe, the asymmetry of these records is an unexplained anomaly. We have memories, photographs, and detector logs of the past, but absolutely none from the future. To explain why the block contains this severe asymmetry, eternalist models are forced to bolt on highly specific, arbitrary thermodynamic boundary conditions after the fact. In a dynamic ontology, this asymmetry is the expected baseline. The physical maintenance of records, like dinosaur fossils, radiation tracks, or geological strata, is the bedrock of existence. This preservation is natively driven by the universe's entropy gradients, locking information into durable states that observers can access. The past is not a persisting geometric region of spacetime that a time traveler could visit. It is simply the ongoing physical maintenance of these truth grounds, carried forward and actively available for cross-checking in the present. To exist in situ requires the capacity to make a discriminable, recordable difference in a physical interaction. Reality is built entirely on the production and survival of evidence, rather than the passive occupation of abstract mathematical coordinates. At microscopic levels, quantum mechanics actively undermines the idea of a single pre-existing catalog of facts, best demonstrated by the Wigner's friend paradox. The Wigner's friend paradox is a thought experiment where an observer inside a lab records a definite measurement, while an outside observer mathematically models the entire lab as existing in a superposition of multiple conflicting states. This forces us to redefine how a fact is generated using a concept called the meeting engine. Reality is an ongoing field of change where facts are not pre-rendered, but are created exclusively through physical interactions between intersecting patterns of co-change. A local quantum interaction only becomes a robust, objective fact when it undergoes environmental decoherence. Decoherence is the physical process by which a fragile quantum state interacts with its surrounding environment, leaking its information outward and leaving behind a stable classical outcome. This dynamic framework perfectly aligns with relational quantum mechanics. Relational quantum mechanics posits that a physical system only has definite, realized properties relative to the specific system it is interacting with. There are no free-floating properties waiting to be discovered. There are only outcomes generated by physical meetings. Objective reality is not a static list of events sitting in a four-dimensional container. It is the physical overlap and alignment of these stabilized, propagating record networks, agreeing on the outcomes of their shared interactions. Treating time as an invisible, flowing cosmic substance obscures a blunt physical truth. All clocks, without exception, are simply mechanical change processes. They do not detect an external river of time. They merely cycle through internal physical states. We can formalize this with the Tau schema. The Tau schema is a logical framework that treats time not as an absolute container, but strictly as a relational ledger used to compare one physical change process against a standard reference process. This visualization shows that duration is not an absolute independent property of the universe. It is a gauge-fixed representation, a comparative ratio linking the cyclic frequency of something like a pendulum swing directly to the frequency of an atomic wave. This relational ledger natively accounts for relativistic path dependence. Because gravity and velocity alter physical processes, different local contexts yield different comparative change ratios between two systems. Operationalizing time via highly constrained atomic comparisons is exactly how modern metrology functions. We calibrate our entire global infrastructure not by tapping into a master timeline, but by standardizing the physical comparison of atomic oscillation rates. Time is a derivative, operational bookkeeping tool abstracted entirely from physical change. It is not an independent spatial dimension that holds events inside of it. A static block model dictates a fatalistic universe where tomorrow's events are already settled, positioned further down the coordinate line. A dynamic ontology preserves genuine, objective openness, requiring that the future is actually undetermined. To maintain scientific rigor without fatalism, we use the constraint state. The constraint state is the complete, current package of physically available records and dynamical regularities that strictly govern what a system can do next. The probability space projecting outward from these nodes defines the admissible continuations. These are the strictly governed, mathematically bounded pathways the world is permitted to take without violating the physical traces that have already been stabilized. Because of this structure, future-directed claims carry graded modal strength. Modal strength is a measure of probability or physical warrant, indicating how likely an outcome is, given the current constraints. Future events do not have pre-installed determinate truth values hidden somewhere in a 4D block. They have probabilities based on present evidence. The future does not exist as a pre-rendered territory waiting to be discovered. It is solely the structured space of physical potential, strictly bounded by the established constraints of the present. The core failure of the static ontology is a misplaced physical burden. By treating a four-dimensional mathematical map as metaphysical bedrock, it forces physicists to bolt on the arrow of time, environmental decoherence, and future modality as clumsy aftermarket afterthoughts to make the math match our observations. Discarding the static block model does not destroy the utility of physics. Instead, it reveals the vibrant, interactive physical network that actually underlies our reality. In this dynamic framework, objectivity is achieved through the physical overlap of independent records. The past is strictly fixed by the survival of material traces, and the future is structured entirely by present constraints. Four-dimensional space-time geometry remains an indispensable, highly powerful compression tool. It is the best method we have for mapping these complex dynamic relations across vast distances and varying reference frames. The success of that geometry does not force us into a frozen universe. Reality is not everything at once. It is the ongoing, physically disciplined architecture of change.